So now we continue our discussion, lecture 15 from the book, and it is on polymorphism and virtual and abstract objects. So imagine that we have a vehicle. What kind of vehicle? I don't know. You just don't go into a store and buy a vehicle. You'll go to a bike shop and buy a bike. You go to an auto dealership and buy a car. You'll go to a marina and buy a boat. They're all vehicles, but they are all specific types. And even, we have a two-wheeled bike. If we put a motor on it, we now have a motorcycle. We make a car something larger, it now becomes an RV. So we can't exactly create a vehicle object. So that vehicle object we call as being abstract. We can't make it, but it stores information that all of these from the lower hierarchies can use. So you might say, well, why do we have a vehicle if we can't make an instance of it, if it's abstract and we can't create it? Well, when you create a bike, the bike will automatically invoke the parent and create the information here. Same thing with the car and the boat in this example. And sometimes in the vehicle object, it will tell you, okay, fine, if you instantiate me and make an instance of me for your use, you're also going to do me a favor. You are going to make a guarantee that you will write something for everyone below you to use. In this case, maybe we want to know about the distance, the average distance, the speed, the fuel economy that these objects have. They're all going to be different. They're all going to use different fuel. Bikes ride on hamburgers that the bicyclist uses to power his bicycle. And we have motorcycles on gas and I don't know what other fuel, is it diesel? I'm not sure. Cars, certainly gas, electric, diesel. RVs, again, using a high level, maybe gas or diesel. Boat is a marine fuel, so they're all different types of fuels, and because you made an instance of vehicle, you've also brokered into an agreement that you will also track what these objects are running off of. So down here I wrote these notes here. The vehicle object at the top of our hierarchy cannot be instantiated directly, and we'll use the keyword abstract when we declare the object to say that it can't be created directly, but it can hold a speed and a fuel average variable. We make an agreement to write speed and fuel average, these two methods, for all of the inherited objects. We call those virtual functions, and again, it's the agreement that we're going to write them. UML has them as italicized. And virtual functions allow us to achieve polymorphism, the ability to change. Polymorphism, it's from the Greek. Poly means many, morph means change. So the fuel and the speed economies can change based on what suits it best. Obviously, cars anymore have good fuel economies. RVs really can take a drain on the gas tank, and they don't have the same speed. You're going up a mountain slope, car will go faster than an RV, so their speed is different in terms of miles per hour. Boats aren't miles per hour, they're knots, which is a speed of a distance per hour. Okay, so if we look at the UML, which is up here, here's the vehicle, and in curly braces the word abstract. Okay, so you can't directly create a vehicle, but we have a type. Maybe here in this parent class we know that we're a bike or a boat or an airplane or something. What's the distance it travels, the hour that it takes, again, and it can be of type double, fractional distances, fractional parts of an hour, and how much fuel, again, fractional parts. We can instantiate the object, our setters and getters, get speed, get fuel average. They're italicized, which means you're making an agreement to write them. Down here, the car inherits from vehicle. Maybe there's a make and a model. With cars, we're interested in make and model. So when we construct the car, there'll be the type. By default, it will say that it's a car, the make and the model, and we also give it the distance, the hour, and the fuel, and we can set and get those if we all of a sudden have a faster car or more efficient fuel or a better time that we travel the distance of. And here in italics is the italicized get speed and get fuel average that we've made the agreement to write. Okay, so there's abstract, there's the virtual, and the polymorphism was discussed that these have different speeds, and pretty much these four objects here are all graded in miles per hour, whereas the boat is in knots. And maybe if we're looking at subatomic particles that travel so many meters per second, that's another speed element. Or maybe we've got something that has a rate that's tracked as like beats per second or beats per minute, like a heart or some kind of a pulsating object that we need in some mechanical device. Okay, so again, it polymorphs to change to whatever it is that we want to use it for. Okay, so there's a brief discussion on the major keywords of this: abstract, virtual, and polymorphism. Okay, and then the